Hello again. Today we complete the review of current scientific NLU problems so we can move on to the solution next time. To recap, we questioned the hypothesis that the fundamental aim of linguistic analysis is to understand its grammar and structure. Well, that may have been a great idea which aligned with behaviorists in the 1930s, 40s and 50s. Excluding meaning has been a roadblock to NLU because it creates an unsolvable combinatorial explosion. As a result, parsing and NLU is said to be AI complete, something that cannot be done until all of the problems of AI are resolved together. And then we saw Stanford professor Daniel Dyirbal report in 1996 that parsing is an NP complete problem when applied to full human languages. That means parsing is impossible. Today we look at the other major issue with parsing, the associated building blocks that create the feared and unsolvable combinatorial explosion. The solution is introduced. Adding a dictionary without the ambiguity of definitions caused by parts of speech, and using meaning instead to avoid the data loss caused by rules. Does the mainstream, and by mainstream I mean formal and computational linguists, still believe that languages are built on grammatical elements like parts of speech? Yes, they do. And we saw last time this was one of the elements brought to linguistics by Bloomfield for the immediate constituent analysis in the 1930s based on his research into ancient language models. Let's look at some examples to highlight my point today. As more diverse languages are analyzed, the solution to NLU becomes an integration of syntax, semantics, and discourse pragmatics. That is, the solution becomes role and reference grammar. I call the analysis of a human language with RRG simply pattern matching. It relies on patterns of hierarchical bidirectional link set patterns, but it is pattern matching nonetheless. Answering questions in context, like those from the Facebook research team, is still just an exercise in pattern matching and set operations like intersection and union. That is an application of pattern theory. I know that there are a lot of computational linguists and all will question how their model is undermined by real NLU. But as Galileo said when confronting naysayers against his telescoped observations of the solar system, quote, "In questions of science, the authority of 1,000 is not worth the humble reasoning of a single individual." Okay, today we're going to look at the parts of speech, and you can see here the determiner, noun, verb. These are the parts of speech themselves, and then their phrase forms, the noun phrase, verb phrase, and so forth. That was the 1930s model from Bloomfield, and over here we've got noun phrases, we've still got nouns and determiners. So fundamentally, this formal language theory and derivation trees are pretty much unchanged for nearly the last century. Now, what we saw last time was that the structure, so if you just look at language with syntax only, the structure produces grammatical and ungrammatical sentences. So, colorless green ideas sleep furiously is arguably grammatical, running, runnings, run furiously is ungrammatical, and then small round birds eat hungrily is grammatical. Only one of those is meaningful in the type of sense where that would be used in perhaps conversation to talk about birds. And then underneath that we've got the different forms of parts of speech that are used. So the original ones like adjective, noun and so forth were too simplistic to be used for the modern corpus linguistics. So the NNS, for instance, gives us a plural noun, and the verbs and so forth are given more definition than you'd get simply with noun and verb. So they represent compounds of meaning, so nouns plus some type of meaning aspect. And here's the problem that you get from syntax only. You then have this question of how do you learn this? So if you've got colorless green ideas being adjective, plural noun, how would you learn that token NNS exists? And it seems to be mission impossible if you're trying to get those particular parts of speech. But if we're working off meaning, it's no longer a challenge. And what I'll show later in the series is how language learning works. In 2017, the experts in computational linguistics are using the same models that have been used for a long time. So here we can see from Professor Chris Manning's 2017 presentation on deep learning, how you start with either the symbols of phonetics with speech on the one hand, text on the other hand, but then there's the word analysis, morphology done next, followed by syntactic analysis, which is again the analysis of the parts of speech, then the semantic interpretation, so what do those parse trees mean, and then discourse processing. So for whatever reason, it's being done as a pipeline, and I think that then creates an unsolvable problem. So syntax alone just doesn't have enough information to work out what somebody's saying in a conversation. Why do we need that model? Well, let's have a look at the models that we're dealing with here. So here's an English syntactic model using role and reference grammar analysis. There you can see that the predicate of speared has an actor of the man, the wallaby is the undergoer, and then we have this thing that actually wraps the whole thing in the mountains, which sits above that predicate. So in the mountains positions the man spearing the wallaby. So that's an English analysis, which will now contrast with this one. So here's an Australian Aboriginal language. You've got the same components there. You've got a man spearing a wallaby in the mountains. But in this case, mountains is identified separately and added as the predicate above that other predicate, speared. And what makes the Australian Aboriginal language interesting is that it's completely free word order. So the verb can come at the beginning of the sentence, at the end, and all of those words can be shuffled, and it means exactly the same thing because the words are marked with inflections in order to do that. And here's yet another language which really refutes that concept of we'll do morphology first and then syntax second. And this one is a Georgian language where the one word means he gave it to her. So that group of elements under core is he gave it to her. Now, the man, the woman, the book in their language is then combined in order to get the sentence, the man gave the woman the book. Now, because that one word actually has the whole sentence in it, it's hard to argue that syntactic analysis showing the relationships of the words is separate to morphology. It's actually part of the morphology. So the world's languages help clarify that we have to solve this entire problem altogether. Okay, now here's how a dictionary works. We've got the man runs, the men run, the man ran, the man is running. We've got these different forms of the particular definition, particular meaning of run. So run, in the case of the man run, is always this same thing, but we're adding elements of meaning. So singular is an element of meaning, third person is an element of meaning, present tense is an element of meaning, and those elements of meaning then contribute to the entire sentence. Or as I like to say at the bottom there, form follows meaning. The point is that the dictionary definition covers all of those elements. And so you think, wow, that's really efficient, but it's not. It's terrible, because when we go to this, we then have three definitions for the same thing. So you can see the WordNet definitions at the bottom. WordNet's just one of the different sources of dictionary definitions, obviously. But in the first example, the running man, running is an adjective. In the second, the running of the man is a noun. And in the third, the man is running, it's a verb. But in every case, the meaning of running is a predicate. It relates man. And in every case, man is a referent. It's a particular thing that we're referring to. So one of the first things that we've done is we've gone away from this model of parts of speech driving the language to just one predicate. And then what we're going to do in the future is we're going to look at one of our solutions to the Facebook artificial intelligence test, where all of these different words have roughly the same meaning, the same core meaning, which is some type of association of have, and then we're extending that with the actual meaning of that word. So we've been able to further compress the entire dictionary with this technique. So that's coming up later. Now, here's the problem that we have with parts of speech. We create data loss. It's really the result of the rules-based system, but parts of speech are the elements that are being mapped onto, and we lose data as a result. So here's the example. You've got the traveling, which is a noun phrase, so the traveling would be replaced with NP in a parser, and the cat will also be replaced with NP, but they're really completely different concepts. So when you extend that noun phrase with to Chicago is simply represented as PP, prepositional phrase. So the traveling to Chicago and the cat to Chicago, doesn't make any sense, are both represented by extending the part of speech to NP-PP. Okay, so that's a significant problem. Whereas the meaning, if we look at the meaning of the traveling, it means travel. There's some sort of predicate travel that we're going to be working with, and the cat is a referent. It's some type of thing. And I know you can argue, look, there's lots more definitions and so forth, but just making the point here, we could talk about the complexities and the solution to those complexities at another time when we get into how we've actually solved this problem. Now, if we extend the meaning of travel with to Chicago, you've got the predicate travel and then a goal, Chicago. It's unambiguous. Traveling to Chicago is the place that you become at. You're in fact, Chicago. You're in Chicago, and then the next example, it's invalid. Referents don't have arguments. Not like that. So a lot of the prepositions that are very hard to work with in a part of speech only model are actually easily resolved with meaning. We have started this series with a review of where the science is and demonstrated an NLU in action, breaking through those limitations. There's a long way to go in the series as we switch focus from what didn't work to what does work. In one sentence, NLU has been impeded by a desire to parse sentences independently to context and meaning based on parts of speech. As we go forward, we will see how pattern theory enables language learning and how NLU is possible by using the extensive observations of the mature linguistic model, role and reference grammar, from a wide array of diverse languages. Next time, we will look at how the duplication of definitions across parts of speech is resolved by meaning-based analysis to leave the combinatorial explosion of standalone syntax for human language in the past, where it belongs.